In this video, I'll be talking about 2D arrays. And by the end of this video, you should understand the concept of 2D arrays and its structure. You should learn how to initialize, access, modify elements in a 2D array. You should also be able to explore the tic-tac-toe game and how it's connected to a 2D array. So let's start with a little bit of introduction here. What are the things we want to know about 2D arrays? So here we'll learn grids, we'll learn rows and columns in programming, more generally speaking. And these are the key points when we're discussing 2D arrays. Each element in a 2D array is identified by its row and column index. And as you can see, we have 0, 0, and indexes start from 0. And so this is just a sample 3x3 grid where you have 3 rows, 1, 2, 3, and we have 3 columns. So we have 3 rows this way, and we have 3 columns this way. So when you look from top to bottom, what you're looking at are the columns. When you look from left to right or from right to left, whichever way you choose to look at it, that would be the rows. More technically would be when you look at it horizontally, what you're looking at are the rows. And when you look at it vertically, what you're looking at are the columns. And just as I earlier pointed out, indexes start at 0. So you can start numbering the index. For instance, the first row has an index of 0. The second row, which is these here, has an index of 1, and so on and so forth. And we can also label the columns as well. And so the first column, which is looking from top to bottom or looking vertically, the first column has an index of 0, the second column has an index of 1, and so on and so forth. Now let's look at real-life examples of a 2D array. Where can we use 2D arrays? You think of grids in games like tic-tac-toe, which we'll dive deeper into. We think of something like chess, and you think of something like Sudoku. So those are great examples for real-life examples of a 2D array. Another example we can think of is seating charts in classrooms and theaters. So because we know, for instance, that this is a seating chart of 1, 2, 3, 4, 5, 6, 18 seats, all right? And that is also another example of a 2D array. Another example we can think of are spreadsheets. So if you've worked with a software such as Microsoft Office Excel, one thing you see is that it's organized in this rows and column fashion, more like a tabular fashion. That's another real-life example of a 2D array. Now, can you think of any other examples where rows and columns are used in real life? I'll leave that up to you. Now, let's look at how to declare a 2D array in Java. Following the example of our grid, we want to write it out like this. First, we need to find out, or we need to figure out what data type we're storing in that array. So in the case of the example we earlier gave, we're storing an integer. So we write out int, and then the square bracket, 2 of them, and the name of the variable. And we assign that to a new int, and we specify the row and column. And let's just dive a bit deeper into this. So what this int 2 square brackets does is that it declares a 2D array of integers. And if we look at the right-hand side, we have this square bracket, 3, 3. And what that does is just to create a grid with 3 rows and 3 columns for us. And so to color code this a little bit would be to think of this as representing the type. Now, this type can be primitive. It can also be reference. So we can talk about things like student. We can talk about things like employee, and so on and so forth. It could be string. It could also be a primitive type, double, float, int, long, and so on and so forth. Now, the 3 here, as you can see here, these 3, which of course corresponds to this color, represents the number of rows. So if we know, of course, we should know when we're working with 2D arrays, because they are of a fixed length, we need to know ahead of time how many rows and how many columns we have in that structure. And so in this case, the first square bracket, the value that goes in there represents the row. So how many rows do we want to have? That goes into the first bracket after the new whatever data type you have there. Now, the second part of it is this part here. So this here represents the number of columns. And so to put everything together, we have int, 2 square brackets, to represent that this is a 2-dimensional array of integer. The name of that 2D array is grid. And we want to allocate somewhere memory for this such that we have 3 rows and 3 columns. How do we visualize a 2D array? Now, this is what the layout of a 2D array looks like in memory. So say we write this out in our programming. Int, and then we have the square bracket, grid equal to new int, and we have 3, 3. What that does for us is just to create something like this. So you see this grid, we have it labeled for us. So we have 3 columns. Again, from top to bottom, that's the column. From left to right, that's the row. So we have 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. And notice now that even though we did not include any value, or we didn't insert any value into this grid, by default, the values that get assigned is the default value of the data type. So in this case, for instance, this is an integer. The default value of an integer is 0. And so 0 gets assigned when we declare and initialize this 2D array. Now, how about if we have something like student and a 2D array of student called students equal to new student, and we have 3. Again, notice here, this represents the row. So if we look from left to right, that's the row, 1, 2, 3. That's the row. And from top to bottom, that's the column, 1, 2, 3, 4, 5. And so this structure here means that we have 3 rows and 5 columns of a student, of course, of a student type, 2D array of a student type called students. Now, how do we access elements in a 2D array? Now, I understand that we're not doing anything about programming, just writing out codes just yet. As with all other topics in programming, more generally speaking, understanding the concept really helps you to understand how to work with whatever that topic is. So please bear with me if this feels too long and you're just watching this, but you're not writing out any code just yet. I need you to understand the concept, and that's why I'm taking some time on this just for now. So the general syntax to access a 2D array is the array, what's the name of the array? And then the square bracket, we want to write out the row, and then we close the square bracket, we open another square bracket to represent the column, and we also close the square bracket. So you use the row and column indices to access the elements. And we'll see what this means just in a moment. Let's look at an example. So let's say we want to access this grid row. For instance, we have grid and we have row column equal to value. That's how you assign a value. And how do you retrieve that value is by getting the data type. Of course, type out the data type of that value you want to retrieve. So for instance, in this case, in our example, we know that grid holds or stores integer. So we say int, and we type what's the variable name, x in this case, equal to, that's assigning, we are assigning this grid, whatever is in it, we want to assign that to this variable x. So to assign 5 to the first row and the second column of our grid would be the first row. Again, recall just from that picture of the grid that the first row is this 0th index. So the way to access the first row is by using this 0 index. And the way to access the second column is by using 1. All right? And so again, take note that row comes before column. And don't flip it the other way around because you get a different result. And if we try to now do system.out.println and we pass this into it, what we get is 5 as our output. And so let's say we have these lines of code. Int, of course, this is a 2D array. I don't need to stress that again. I believe by now you understand what this line does. But here, we're assigning 5 to this grid at this column, at this row, at this row index and at this column index. So the way to do this and the way to picture this is this. So look at this place. The row is 0. We can draw a line there like that. And the column is 1. and we draw a line on the column 1. Now, wherever there's this intersection, that is where the value, that is where we want to write out the value. And I'm saying this so that when you're writing it out, maybe on a piece of paper or any other device like that, when you're handwriting, you can easily picture where you should fit in those values. So if we had a grid of 1, 1, that would mean we want to look at 1 here, strike it out from left to right, and then 1, strike from top to bottom, and that would intersect right here. So a grid of 1, 1 would be here. So how about you taking some time to just picture these? What do you think? How do you initialize a 2D array with 2 rows and 4 columns? How would you go about that? The other question I want you to ask yourself at this point, and which I would say, if you can't answer these questions, then you want to pause this video or go back to the beginning where we talked about how to initialize a 2D array and try to understand that and come back to this quick check. Make sure you're able to solve this problem. What is the value of grid 2, 1? After we do this, what would the value be? And I'll leave that to you. You should be able to figure out what happens when you do this. So I want you to draw this out. When you do this, what happens? What's the value that gets stored in here, in this structure? And what happens when you assign 7 to this line of code here? So what are the key points? Accessing an element requires both row and column indices. So you can't just have one or the other. It has to be both of them. And ensure these indices are within bounds. So for instance, you don't want to call grid 3 here because we don't have an index labeled 3. The highest index we have here is 2. So you want to make sure you're checking for that. Now let's look at Ansonic's example on initialization and access. And here we'll be building and working with 2D arrays. So how do we initialize a 2D array? We've talked about this. Int grid equal to new. We have int 3 to represent the rows and this 3 to represent the columns. And recall I said if you do something like this, what happens in memory is that it gets you the default value of whatever data type you have here. So in this case, again, it's an integer. For double, it's 0.0 and so on and so forth. For string, it's null. That's what gets stored when you do something like this, when you declare and initialize a 2D array. Now, this is what I've just said. The array is filled with default values of 0. Please take note that this is not a generic thing. If you have an integer here, the array is filled with default values of 0. If this was a double, then it will be filled with 0.0. Please take note. Rows are indexed, again, following this example, rows are indexed from 0 to 2. And columns are also indexed from 0 to 2. So these are the columns, 0, 1, 2, and these are the rows, 0, 1, 2. So I would encourage you that you should practice, try to understand what the rows mean, how do you view it, and that's the reason I color-coded this as well, just so you know what is mapped to what. So for instance, you know that this is for the rows, there's 3 rows, and this represents the columns. You know that these are the default values of 0 in this case, again following this example, and that the rows are indexed from 0 to 2. Again, looking from left to right, that's the row, and from top to bottom is the column. Now, this is a question I want to ask you. What would change if we initialized a 4x5 array instead? What would change? And I'll leave you again with that question. But is it all the time we have to do something like this? Do we always have to do int grid equal to new int 3? So say we already know what the values in this array is. The shortcut we want to use for initializing that 2D array would be to do something like this. So int, we have the square bracket grid equal to, and this time around, we're not saying new int because we already know what the values are going to be, because we know what values we want to store in the array. We just go ahead and write one curly bracket first, and then another curly bracket to indicate the first row. So as you can see, this here, the number you type in to the first curly bracket goes into the first row. So 1, 2, 3 stored in the first row, 4, 5, 6 second row, 7, 8, 9 third row. And notice now that after each curly bracket, there is a comma here to specify that this is the end of this array. And we're starting another one. And so starting another one, we want to also enclose that in a curly bracket, type out all the elements in that array. Of course, we delimit it with the comma. So we separate the elements with the comma. And then we also close this, and so on and so forth. And at the end of the third array, notice that we didn't have to include another comma because there's no more array we want to add to this. And after that, we close the outer array here. So how do we modify elements of a 2D array? Or in other words, how do we update an element? We've talked about this, just array, pick the row, pick the columns, and assign a new value to that. But one key thing I want to talk about here is that you use row and column indices to access an element. So that's the first thing you want to do. You want to access the element first, and this gives us access to the element. So when we're able to say grid 01, that enables us to access that element. And then the second thing is to assign a value to the element. Of course, the type has to match. So you don't want to, say for instance, you have an array of grid, and here you are assigning a string to that array of grid of integers. So you don't want to do that. You want to make sure that the new value you are assigning to it also corresponds to the type of that array that you had stored. So let's take a look at an example. This is not something new again. It almost looks like I'm repeating myself, but grid 0, 1, 0, row 1, column. And we have 5 here. And please know that this is just for beginners, and that's why I'm stressing things like this. So if you already know these things, you can skip forward and see maybe there is something new you can probably learn, but this is for beginners. So now let's look at this program. This is what it was before. When we run this program, this is what we would get. Now we're adding 2 lines to it. We're now saying grid 01 equal to 3. Notice that before we said grid 01 equal to 5. Now we're saying grid 01 equal to 3, and grid 1, 2 equal to 7. What's happening here? Initially, take a look at this. We had 5 here, right? Because this is the 0th index of the first row, and this is the second column, or the first index, right, on that row. So we're saying we want to change that value to 3, and that's why you notice here we have 3. And here we're saying we want to look at the first index, which is this, index 1, and column index 2. Again, if you picture this, striking a line here and striking a line here, where do they intersect? Right here, right? And we're assigning 7 to that particular element. So this is how we update the value of a 2D array. So what's the key point here? Elements in a 2D array are mutable. And by mutable, we just mean that we can change the values. We can update the values. We can update the values of the element. Now, please take note that arrays are of a fixed length, and so we can't change the size of the array itself. So if, for instance, we have this grid as 3 by 3, we can't possibly try to grow this array or to shrink this array. 2D arrays are not that kind of data structure that give you such flexibility. There are other data structures that enable you to do this. ArrayList is one of them. But 2D arrays are of a fixed length, and so you can't change, you can't grow them, you can't shrink them. However, the elements in this array, so for instance, we can change whatever value is stored in here, we can change whatever value is stored in here, we can change whatever value is stored in here. However, we cannot change this structure. We can't add one more column to it. We cannot add one more row to it. I wanted to stress this because I know that this can be a confusing part of 2D array. So how do we iterate over a 2D array? What we use is nested loops. Now, remember that when we wrote out the shortcut, we had 2 curly brackets, right? And even if you, still notice that when we wrote the grid, we wrote int, and we had 2 square brackets, right? And that just tells us that there's one outer loop. So the outer loop iterates through rows. The inner loop iterates through columns in each row. So for us to iterate over this 2D array, we want to have the row, of course, starting at 0, because we have the indexes starting at 0. And again, this is not something that is, this is not a rule of law, right? Depends on what question you're tackling. Would give you a sense of where to start and where to definitely end. So, but in this case, we have row equal to 0. Row is less than grid.length, and we'll look at this shortly. And we have row plus plus. And we have this curly bracket. Within that curly bracket, we have another for loop. For int col equal to 0. Col is less than grid. Now take note here. The difference between this and this is that this gives us the number of rows we have in that 2D array. And that's why we didn't need to specify anything, because if you take a 2D array and you type out the name of that 2D array and you do dot length on it, what it returns to you is the number of rows in that array. However, for the inner loop, we need to specify that we are referring to this particular row. And so the way to do that is, so say for instance, we're looking at the first row, which of course has an index of 0, right? And you will see this shortly, but I'm just stating here that, say for instance, the first row would be grid 0, right? Dot length, and that would give us the length of the first row. So how many elements can we possibly store in this first row? That gives us this value. And then whatever we want to do with it goes into this second for loop, which of course is referred to as the inner for loop. And so once we're done with anything we want to do in the inner for loop, we might want to do something else before we then go into the outer for loop end. So let's look at how to use this nested for loop, and let's take a look at this example. The first line, we have int, we have the 2 square brackets, grid equal to new int 3, and of course I've explained this, right? When we do that, what happens is that we have a place in memory that gives us this kind of structure where all the initial values or the default values of an integer is stored in that location. Now, the next thing is we go to line 2. And I needed to keep an eye on the line numbers as it's changing, and just a few highlights I'll be making here and there. So for instance, grid.length, I just explained that grid.length returns the length of the rows of the array. In this case, how many rows do we have? 1, 2, 3. 3 rows, right? And so it's like saying row less than grid.length just returns true if row is less than 3. So what we're saying is that we want to iterate from 0. Notice that row starts at 0, right? So it's like saying we want to iterate from 0 to 2, because this is less than. We're not going up to 3. And notice how that the grid, the indices here are labeled from 0 to 2, right? And that's why we have less than here, because grid.length would return 3, and we don't want to get to 3. So we are saying whatever the row is at that point, we want to compare that and make sure that it's still less than 3. We don't want to include 3. So at this point, row is 0. Now grid row dot length returns the length of the columns in each row. So for instance, in the first iteration, we have the grid 0, right? Because row at this point is 0, right? Look at it here, row equal to 0. And we're saying grid of 0. It looks at this place, and it's like saying how many elements do we have here, or how many elements do we have in the first row, and that gives us 3, right? Because grid 0 has 3 elements. So grid 0 dot length returns 3. All right, I hope that is clear. So we ask ourselves this question: col, which of course starts at 0 again, less than grid of 0 dot length, as in the case of the first row. It returns true if col is less than 3. That is, we're also iterating from 0 to 2, but not including 3. Now, it's not all the time that you see this kind of structure where the number of the columns, the number of rows is the same thing as the number of columns. But in this case, that's what we have. And so we take note of that. All right, on line 4, what do we have? On line 4, we have this system.out.print notice that this is print, right? And we're printing out the grid of the row and of that column. So in our first example, the row is 0, the column is 0. And so when we say grid, row, column, we're saying grid 0, 0. What's grid 0, 0 in this case? So what would be the first output? 0, grid 0. Look at the 0th index of the row. Look at the 0th index of the column. And that gives us this value right here. And that's what gets printed out for us. So row is still 0, column is still 0. Grid 0, 0 returns a value of 0 and 0 and gets printed to the console. And so what we see is this first output here, 0. What happens after that? We want to go back to line 3 and ask, we want to, of course, look at col plus plus. We add 1 to the value of col. Col initially was 0, right? Now we're adding 1 to it, 0 plus 1. Col now becomes 1. And so we're asking ourselves this simple question. Is 1 less than 3? What's the answer? Yes, right? Then, if that's the case, move to line 4. On line 4, what do we have? We have the system.out.println, right? And we know that row is still 0. Row hasn't changed yet, but col is 1 now. And so grid 0, 1, which is, look at this red highlight here, returns the value of 0, and that gets printed to the console here. And we go back again to line 3. Notice how that this col plus plus, because we have it there, it still had 1. Initially, col was 1, right? We had 1 to that value. Col now becomes 2. Now, the next question is 2 less than 3? Right? Because col is 2 at this point. Is 2 less than 3? Well, the answer is still yes. Yes, it is. Okay, if that's the case, then still go ahead and execute line 4. And what do we see? Grid 0, 2. What do we have in there? 0 as well. And that gets printed for us. He goes back again to line 3, adds 1 to what was the last value? 2. If we add 1 to that, we now have col becoming 3, right? And then we ask ourselves the same question. Is 3 less than 3? Well, the answer is no, because look at this. We don't have any part on this diagram where we have grid 0, 3. We don't have a third column index, right? We have an index of 2, and that's the maximum we can possibly get. Now, because that's the case, we want to move to line 6. And so on line 6, notice how that we now have ln. The ln on the line 6, which of course we have here, system.out.println. So notice the difference between this println and print, right? This enabled us to print side by side without having to move to the next line. When we have ln, what we're saying is that move the cursor to the next line before printing anything. I hope that's clear. So the cursor now, even though we can't really see it, but the cursor moves to the next line just by doing this. Now, after that line, we go back again to line 2 and we add 1 to the row. Of course, now the same kind of procedure we did for col plus plus is the same thing we're doing now. Back to that line, we had 1 to the row, right? Initially, row was 0. Row now becomes 1. Now, if row is now 1, what do we have? We have row equal to 1, column equal to 0 on line 3. And we still ask ourselves, what's the length or how many elements do we have in the second row? And as you can tell, we have 1, 2, 3 elements, right? And so we want to know if the col is less than 3. That must be true if this line 4 must be executed. So we ask ourselves, is 0 less than 3? The answer is yes. And if that's the case, we want to move to line 4. And line 4, we want to just print out the value of grid 1, 0. What's the value of grid 1, 0? That's this right here, right? And that gets printed to the console. And so this is what happens. This is what keeps the cycle continues, the iteration continues until the conditions are no longer true. And so it exits out of both the inner for loop, of course, the inner for loop first, and then the outer for loop lastly. So here's a mini task for you. Your task is to write a code to initialize a 5x5 2D array. And once you're done doing that, assign the value 9 to the center cell. And then print out the updated grid to the console. But let me add a little bit just an extra here. Before you print out the updated grid to the console, print out the initial grid before you assign. So now I'm saying initialize a 5x5 2D array, print that 5x5 2D array, and now assign the value 9 to the cell, to the center cell, and then print out the updated grid to the console. I hope that task is clear. So in summary, what have we done? What have we done? We've learned how to declare, how to initialize, and how to access and modify a 2D array. We've used nested loops for the iteration. Now that you've practiced the basics, hopefully, if you haven't, I encourage you to pause this video, go and do all those exercises. Make sure you complete all those exercises and then come back to this video. And the reason for this is that I will be pushing some of these codes to you, and you'll be the one doing some of these things. However, of course, I'll be doing them, but I need you to do this task so that you can really understand how this whole thing works. And now that you've practiced the basics, let's see how we can use 2D array to build something fun, a tic-tac-toe game. Now we want to bring 2D arrays to life, and so we'll be building a tic-tac-toe. This is a tic-tac-toe project. We'll be building a tic-tac-toe game, and we'll explore how 2D arrays can be used in real-world applications. And this is what a tic-tac-toe board looks like. We've been talking about 3x3, and probably this even makes it a lot easier for you to think about. But this is what the tic-tac-toe board looks like. And this is the overview of the project. We'll be building, or we will build a text-based tic-tac-toe game where 2 players take turns marking cells on a 3x3 board. And what do I want you to learn here? You will learn how to apply 2D arrays to represent the game board. You would learn to use loops to interact with and update the board. You also learn to implement the basic game logic. So something like checking for winners. And so this is a long ride. I'll be honest, this is a long ride, but we'll break it down and we'll see how does 2D array even fit into this. Notice that the board itself is a 3x3 grid, and that naturally maps to a 2D array, right? Because we know what the length of that box is. For those who have played tic-tac-toe game, the tic-tac-toe game, of course, you know that we just draw out 3 rows and 3 columns, right? And each cell in the grid corresponds to a row call in the array. And so when you're thinking of this, you think of something like having a board 0, 0, board 0, 1, board 0, 2, board 0. And this is just to give you a clue. And to initialize, of course, we've talked about the shortcut. So let's say we want to initialize an empty cell, just so the user knows what boards are still yet to be filled. The way we will do that is by using this underscore just to represent an empty cell, just so the players know what part of the board is yet to be filled. X and O would represent the player moves. So what's the end goal here? This is what we're building. This is what the completed game looks like. But before then, let me talk about the features of the project. For the features of the project, we know we have players, right? The player 1 is going to be X, the player 2 is going to be O. We also have game actions, like players taking turn to mark a cell. And we know that the game is going to end when a player wins. So we have 3 in a row, or so if we have XXX in a row, in a single row, or we have XXX in a single column, or we have XXX diagonally, it means that player X has won. Similarly, the same thing goes for the player O. And we know that the board is full. Of course, once the board is full and there's no one who has won, then we know that that's a draw, right? And the output, we want to display the board after each move. And we want to announce the winner or declare a draw, depending on what the outcome is. So let's take a look at this flowchart. We'll start the game. The first thing is to display the board. And we ask the current player for a move. We check if the move is valid. If the move is valid, we update the board. If the move is invalid, we show an error. And we ask again. And that asks the player again for a move until the move is valid. And if the move is valid, we update the board. We check for winner or draw. If a winner is found, we want to announce the winner. If a winner is not found, we want to check if the board is full. If the board is full, then we want to announce draw. If the board is not full, we want to switch to the next player. And once we switch to the next player, we want to display the board again, just so the user knows what part of the board is yet to be filled. And so I've talked about this, how we'll build this project. This is what would use to represent the player moves, X and O, and underscore to represent an empty cell. So what's the end goal here? This is what the completed game would look like. We'll accept player moves, we'll display the updated board after each turn, and you'll determine when the game ends and announce the result. So this is an example of what it feels like here. So we know by looking at this that this part of the board, this part of the board, this part of the board, this part of the board is yet to be filled. And so we can enter move, right, for 2, 2. Now, when we do that for 2, of course, to represent row and 2 to represent column, that looks at the row here, 2, and the column, 2. And that plays the next user, which is O in this case. The next person plays 1, 2, and he plays 1, 2 right here at the center. And what happens, sorry, 1, 2 right here. That's where this player has played. And the player X wins. So this is what the game is going to look like. And this is what we're going to be building. But the task I have for you today is to create and display the tic-tac-toe board using a 2D array. So what are the specific goals here? I needed to initialize the 3x3 array to represent the board, fill the board with underscore to represent empty board, and then write a code to print the board to the console. So those are the three things I want you to do for now. The first is to initialize the 3x3 array to represent the board, fill the board with underscore to represent empty board, and then write a code to print the board to the console. Now, once you're done with that, I needed to think through this. What would you change in the code to display X in the top left corner? So how would you update your board in such a way that you can display X in the top left corner? And this is what I'll leave you with, and I'll see you in the next video where it will start talking about hands-on and walk you through this project. Thank you for watching. Bye.